In this video, we'll begin our discussion of inverse trig functions. So first, let's start talking about the relationship of an inverse. Back in PreCalc 1 or Algebra 2, wherever you've seen this, we had functions that would map something, so just a point to another point, right? Could be 3 to 5, something like that. That's my f. An inverse function just sends it back. That's all it is. It's a mapping of original function but going backwards. So what that means here, we're going to use that idea to help us out, that the domain of a trig function, we normally pick a angle to plug in. Right? We usually plug an angle into sine and we get something out. What we get out is the ratio. So what that means is if things are reversed, like we said a second ago, then to do an inverse trig function, right, then our domain would be a ratio, and it would send us back to an angle. How we're going to note this inverse, and we write it right here, is we put a little -1 in the power between the sine and the x. Like if we were to do sine squared 2, we would do like this to square it. We put the -1. It does not mean like if I do x to the -1, this means 1 over x, like flipping it over. It does not mean that. It just means the inverse. Anytime I have that power like that with a function, we're going to say it's an inverse. So there's my warning I just gave you. It doesn't mean 1 over sine. It doesn't mean to flip it. It actually means inverse. All right, so what this means, if we take a look right here, since sine of pi over 6 is 1/2, then this is how we write it. Sine inverse of 1/2 gets me back to pi over 6. It just sends it back. Okay, the second one, looking at this cosine. Cosine of pi is -1, so pi is equal to inverse cosine of -1. So if I take the inverse cosine of -1, it sends me back to pi. It's just a sending it back, and now we have a notation to go backwards. Same thing with tangent here. We know tangent of pi over 4 is 1, so inverse tan of 1 would be then pi over 4. All right, we run into an issue when we do this, though. If you remember from PreCalc 1, we talk about inverse functions, and we talk about that inverse functions, if I want the inverse to be a function, my original function needs to be a 1-to-1 function. Now, all the words there, the terminology, it's great. I'm going to explain what that actually means and why we have a problem. Okay, take a look here. All right, so I have sine of pi over 6. Okay, if we used our unit circle, that's my short triangle, and sine is my y. So if it's the short triangle and sine is y, that's a 1/2. All right, and then, but if sine pi over 6, 5 pi over 6 is the triangle, small triangle on the other side, and we're still looking at half for our y. So both of these answers are 1/2. So why is this an issue? Well, I'm going to write something down here. The inverse sine of 1/2 needs an answer. But right now what I have is I have two options there at the top that's going to take 1/2 and send it back to pi over 6 or 5 pi over 6. So is it pi over 6 or is it 5 pi over 6? And we could even keep going, and I could add 2 pi's to these and get revolutions, right? I could say, hey, what about 13 pi over 6? And I could add another 12 to that, 25 pi over 6. And I could just keep adding a 12, 17 pi over 6. I have an unlimited number of answers, so which one does it go to? This is what causes this problem. This is why we need a 1-to-1 function. Remember, a 1-to-1 function means that every input has a unique output, right? No other input and output go together. Well, in this case, for our normal function, it's not 1-to-1 because, look, pi over 6 goes to 1/2 and 5 pi over 6 goes to 1/2. So going backwards, we would have a problem. So what we're going to do is we're going to restrict the domain, and we did this back in PreCalc 1. I think you have to do it with square root functions. We start talking about it there. Okay, there's a sentence here. I talked through all this stuff. Sentence here, as with other functions that are not 1-to-1, we will need to restrict the domain. That's what I just said out loud. So we're going to restrict the domain. Graphically, here they are. I don't like that our book gives us this so early. We're going to talk about these later. So I don't need you to stress out about those. I don't need you to sit and stare at them and try to memorize them or anything like that. We are going to eventually graph all of these things. So let's talk about it in a different way. So we need to restrict the domain of inverse sine. How we do this, okay, it's normal range for sine. Remember, sine lives between -1 and 1. So the domain of its inverse is going to be negative 1 to 1. I have to pick numbers negative 1 to 1. If I don't, then I can't plug them in inverse sine, and this makes sense because sine goes back and forth between negative 1 and 1. It has to give me, I have to put in answers that are in that. Now, when I pull an answer out of that sign, just like the issue that we had up here, we got to decide which answer is it. Is it pi over 6 when I do inverse sine right here? Inverse sine of 1/2? Is it pi over 6? Is it 5 pi over 6? It's one of the others. What we're going to do is, if we remember, sine is a y, right? Just a y, and I'll put it in quotes like that because we're using x and y's here. But remember, sine is our y. So if I want to hit all our sines and our sines on those angles, I would like to hit all the y's of my unit circle, which means if I start here and go all the way up, notice I get all my y's of my unit circle. Y's go all the way down to negative 1, and y's go all the way up to 1. So we restrict our answers to be between negative pi over 2 and pi over 2. So earlier when we said sine inverse of 1/2, well, the answer now, it was either pi over 6 or 5 pi over 6 or outside of that. The only thing that's going to fit here is pi over 6. So we have restricted it now that if I only choose angles that are between negative pi over 2 and pi over 2, and this is completely based on the idea of y there, then I can get one answer for each number, each ratio I plug in. No longer will we have that issue. All right, same thing for cosine, inverse cosine. We would run across the same issues there. It still has the same domain because remember, cosine lives between negative 1 and 1. Our unit circle, think about those are the smallest and biggest values we get. But its range, and remember, we let cosines be our x. Well, x, if I wanted all my x's in my unit circle, I would go all the way across like that. Probably a little more symmetric. Not much better, but we'll take it. So notice that covers all x's because cosine is x. So instead of doing negative pi over to pi over 2, we can do 0 to pi. That will cover all of my x's. So sine is negative pi over 2 to pi over 2, all answer inverse sine. The range is negative pi over 2 to pi over 2. All the answers had to come out in there. Same thing for inverse cosine, 0 pi over 2. And then also for the range of inverse tangent, we're going to use negative pi over 2 to pi over 2. And this goes back to what the shape of tangent will look like on a graph. We will get there eventually, but we're going to leave it like this so far. So here we go. To find the domain and range of inverse trig functions, find the domain and range of the original functions and just flip them. That's all you need to do. Here's a graph of each one. Remember that inverse functions from PreCalc 1 reflect over the line y equals x. And we can take a look. If we were to graph these angles based on angles here and ratios, then we would see these pictures. Again, graphically, I'm not really concerned. Our book shows it to us pretty early, but in the next unit, we'll get into actually how to graph these things and what they look like. As of right now, we're just pointing out that these inverse functions do still respect the characteristics of an inverse. Right, here it is formally written out. Right, so this first example says, given sine of 5 pi over 12 is equal to 0.96593, write the relation involving inverse sine. So they just want us to flip it. 5 pi over 12 is equal to inverse sine of 0.96593. That's all they wanted. They just want to rewrite it based on the relationship we were given. Also the cosine at the bottom, 0.5 is equal to, and these are both approximate, I guess, because we rounded. Right, and then it's going to be inverse cosine of that decimal. That's it. Feels a little too easy, but all we're doing is focusing on that when I have an inverse, I plug in a ratio and I get an angle. Right, I wrote the domains there at the top to help us out because we're going to use them right here. So the first one, sine of negative 1/2. Sorry, inverse sine of 1/2, not negative. Right, so we're thinking, when is sine 1/2? So sine is my y, and it's a small one. And then I know sines have to be in the first and the fourth quadrant, and it's positive. So I'm looking at a triangle in the first quadrant because it's got to be a positive 1/2, and then I want the triangle to have the y to be a half. Well, where that happens, that would be the short triangle, and this is going to be pi over 6. So it's just backwards thinking now. Sine inverse of negative rad 2 over 2. This is going to be in quadrant 4 because I know it has to live in quadrant 1 or 4. And it is my middle triangle because radical 2 over 2 is a radical value, or the middle triangle value. This is going to be negative rad 2 over 2 for that side. So that angle would be negative pi over 4. Remember, all the 4s are in our middle triangles. Number 3, we have cosine, inverse cosine of negative rad 3 over 2. Cosine now, if we look here, it lives in quadrants 1 and 2. So it would be, if cosine was a negative here, let me draw these a little better because the notes start looking really bad if they're really sketchy. We have that, and it's cosine 0 through pi, so it's in this quadrant or that quadrant. And it's negative, so it's going to be in quadrant 2 because x's are negative there. And radical 3 over 2 is the bigger side, so x needs to be bigger because cosine's x. Well, that would end up being the short triangle, so that's 5 pi over 6. All right, number 4, that's dealing with tangent. Tangent is between negative pi over 2 and pi over 2, and they want to know when is tangent 1. So the arctan, I need to mention that. Sometimes we use a different notation. Instead of using sine like this, we'll write this instead, arc sine. Some people didn't like the -1 thing. They thought it was confusing, so they just wrote a whole different definition. So those are equivalent. You can use either one you would like, sine, arc sine. There's also cosine, arc cosine, tangent, arc tangent. All of them can be called arc. All right, so inverse tangent of 1, well, tangent's stuck between negative pi over 2 and pi over 2, so it's either the first or the fourth. It's a positive, so it's going to be in the first. And tangent is 1 when x and y are the same. That happens at pi over 4. All right, I have 4 more just to keep practicing. We have the inverse sine of -1. All right, and we want sine to be -1, and I know sine lives in these 2 quadrants, and it's my y. I need it to be straight down, so it's going to be a negative pi over 2. Inverse tan of -1. Okay, tangent is 1 at the pi over 4s, but I want a negative, so it's going to need to be down. So this is negative pi over 4. So this really will come down to how much do you know your unit circle. If you know your unit circle pretty well, this is just applying the unit circle backwards. Cosine is -1. Okay, cosine is x, so that would be over, if it has to be in quadrant 1 or 2, then it would be this way because x is negative that way. Well, that's a pi. We have our last one here. Inverse cosine of 1/2. Right? Cosine is stuck between quadrants 1 and 2. And I want it to be a positive, so it's going to be to the right, and it's a half, so that means this bottom needs to be the smaller side, which means it's the tall triangle, which means it's pi over 3, not 6. Pi over 3. So, again, if you don't have your unit circle down by this point, it is the key to practically the whole course. You have to get it down to be able to do the rest of these.